Welcome back to our online class. Today we shall be taking second order ordinary differential equation. So this time around we are not going to be dealing with the first derivative anymore. We'll be dealing with second derivative, and hopefully very soon we'll go to the higher derivatives. Now we have some examples here to treat. You have 2d squared y over dx squared, that's second order, plus 5dy dx minus 3y equals to 0. You can see this form of equation is more of a polynomial. Now, when it is equal to 0, you don't have to stress yourself. What you are just looking for here is just, let's call it the complementary function. In subsequent examples, we are going to be taking questions where your second order ODE will not be equal to 0, but it will be equal to a function, say exponential 2x, say sine 2x, and any other function can be here. And there are ways we are going to approach that. But for the meantime, when you see this type of equation, what comes to your mind first is your quadratic equation. You are going to solve this like your normal quadratic equation. Now, solution. Now, the first question is 2d squared y over dx squared plus 5 the y dx minus 3y equal to 0. Don't forget our aim, we are going to get a root. Like I said, we are going to solve like a quadratic equation. So there will be a way we are going to write the roots for different cases. Let's try for this case. Now, what you're going to do, you can represent this with any letter of your choice. Then it's going to have the power of that order. If I represent this with m or r, it's going to be m squared. The derivative, the y, the x will be m. Then you are going to have 3 alone. It's only the derivative represented with the letters. Take note. It means I can write this as 2m squared plus 5m minus 3 equals 0. I've been able to convert this to a quadratic equation, a polynomial in general. So I have to solve this like my quadratic equation. You look for the factors that fit into this. When you multiply 2 and 3, negative 3 have negative 6 as the product, and your sum is positive 5. I know you are very good in that. So I'm going to have 2m squared. If I try 6m minus m, I'm going to have positive 5m. And 6m multiplied by negative m, I'm going to have negative 6m squared. So that's very good. So I'm going to have negative m plus 6m minus 3 to be equal to 0. Very good. So I can group this in this form. Now, if I factorize, I'll factorize out m. I'm going to have 2m minus 1, right? Plus, if I factorize out 3, I'm going to have 2m minus 1 equal to 0. So from here, my factors, I know that either m plus 3 or 2m minus 1 will be equal to 0. So from here, I know that if m plus 3 equals to 0, my m will be equal to what? Negative 3. Likewise, if 2m minus 1 equals to 0, my m will be equal to 1 over 2. Now, this is the deal. While writing your solution, your solution for this type of the root you have derived is simple. You bring in a constant, let's say c1. Let's say this is for your y1 and your y2, So I'm going to have, let's call it y. In this case, will be c1 exponential. Let's take the first one, negative 3x, because it is respect to x, plus I'm going to have another constant, c2 exponential to 1 over 2x. Now, that is the solution to the first one. Hope you got that right. Now let's take the second question, so that you're going to know that there are different ways of writing this root. Writing this is very, very important, knowing how to write this, because I got real answers. I had -3 +2, so I had c1 exponential -3x plus c2 exponential 1 over 2x. Now let's take the second one. Now this is written in this form: y prime prime plus 2y prime plus 5y equals to 0. So I have y prime prime plus 2y prime plus 5y equals to 0, right? Now this is same as d squared y over dx squared. So I can just make this to become what? M squared plus 2m plus 5 equals what? 0. Now I look for factors. What am I going to multiply together? That, would give me 5, and if I add them together, I'll get a sum of 2. Virtually, well, I can't get those factors. So what I do, I can use computing the square method. You can use the quadratic formula, and whichever method you can use. So if I'm going to select the completing the square method, where I'm going to subtract 5 from both sides. So I'm going to have m squared plus 2m to be equal to -5. Now I'm going to add the square of the half of the coefficient of m to both sides. So I'm going to have m plus the half of 2 is 1. The square of it, so I'm going to have m plus 1 all squared equals -5. The same time I'm going to add the square of 1 to the side, which is plus 1. So I'm going to have m plus 1 all squared to be equal to -4. Now from here I'm going to take the square root of both sides, so that I'm going to have m plus 1 to be equal to what? The square root of is going to be positive or negative, square root of -4. Then from here my m is going to be -1 positive or negative, square root of -4. Very good. Now you can see that this is a complex number. Now I'm going to introduce letter I or j. So I'm going to have m to be equal to -1 plus or minus. If I introduce letter, let's say j equals to -1, so I'm going to have root 4j. So that where j equals to what? J equals to -1. Don't forget. Now, so my m equals -1 plus or minus 2j. Now, I will take this as alpha, and I'll take this as what? As beta. Now, for me to write this type, this is the solution, this is the root. For me to write my y just like this, I'm going to have y equal to the alpha, that's exponential negative what I have, since this is respect to x, -x, what I have here, into bracket, and I have constant, let's say c1 cosine of 2x plus c2 sine of 2x, and that is the answer. So we have a lot of them that we can, with time, the more we continue to take more examples, you are going to see how we are going to be approaching them based on the values you are going to have. So remember, the deal is that you must be happy, I must be happy, we must be happy. So endeavor to like, comment, subscribe, and share. Thank you.